Assalamualaikum warahmatullahi wabarakatuh and very good morning everyone. So for today, we are going to continue with chapter 5 regarding alkenes. Okay, first of all, as we know, alkene will have double bond. Okay, so we can see here at the right bottom corner of the slide, we have ethylene here with C double bond C. So anything that have a double bond without any other functional group, we call it as ethylene. So ethylene is basically a hydrocarbon having 2 C and 4 H. And alkenes are sometimes called as olefins. So this ethylene is actually the largest volume industrial organic compound used to make polyethylene and a variety of other industrial and consumer chemicals. Okay, as we know that we have saturated and unsaturated hydrocarbons. Previously, during the chapter on alkanes, we already learned that alkane has only a single bond. That is why it is saturated. It has low reactivity because they have a non-additional element that will allow them to be more reactive. This, for alkane, it has to react in a condition having heat or energy given to it. But for alkene, it is said to be unsaturated. Why? Because it has the double bond between the two C, thus it's capable to add hydrogen in the presence of catalyst. So the product of alkene react with hydrogen. With the addition of hydrogen, it will result to alkane as the product. So the presence of a pi bond of an alkene or alkyne is a triple bond, or the ring of a cyclic compound decreases the number of hydrogen atoms in a molecular formula. Maksudnya kalau alkene ni dia ada double bond. Ring, dia ada ring lah, cyclic compound ni ada ring. So dalam kes alkene dengan cyclic compound, bilangan H-nya kurang daripada alkene yang merupakan single, dan di sini kita tak masukkan cyclic alkene lah. So disebabkan itu, kedua-dua alkene dan juga cyclic compound ini, structural feature mereka ni dipanggil elements of unsaturation. Kewujudan double bond dan kewujudan cyclic merupakan elements of unsaturation. Okay, cuba kita tengok kat sini. So, elements of unsaturation of hydrocarbon. In hydrocarbons, we can see here, each element of unsaturation corresponds to 2 lesser hydrogen atoms than in the saturated formula. Kalau kita ada alkane which is saturated, kalau kita perasan ikut formula dia ada extra 2H. Mari kita lihat the first structure here we have propane. So prop means 3C. Ane, so it's an alkane. So kita expect it has 3C here. You can see here. C, another C, another C. So 3C. And we have here 3H, 2H, 3H. So in total 3C, H8. Okay, C3H8 lah. This is the saturated compound. Now let's see what happened when we have elements of unsaturation. Okay, the first one on our left side on top, this is right side on top, we have propene. So prop means there is 3C. In, it means it's an alkene, so there should be double bond there. So we can see here, we have 1C, 2C, 3C, so C3. And then 3H, 1H, 2H. Now we have H6. So saturated propane, we have C3H8. Unsaturated propene, we have C3H6. So with one element of unsaturation, we have less 2H as compared to the saturated compound, which is propane lah. Now let's see how about ring. Let's see on left bottom here, we have a cyclic compound called cyclopropane. Still an alkane, but it's in a form of cyclic. So here we have one ring. So because it's one ring, so it has one element of saturation. So let's see how many C we have. 1, 2, 3. 3C. H, how many we have? 2H, 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 resulting to H6. Now the number of C and the number of H of a cyclopropane is similar to the propene, the alkene. So alkene and also cyclopropane has less 2 hydrogen as compared to the saturated propane. Now let's see another. We have propine where we have triple bond. So we have triple bond here, not just double bond, but we have triple bond. So in this condition, if we have triple bond, it's considered that we have 2 element of unsaturation, because not only we lack of 2H, see how many H here, 1, 2, 3 C, so C3, 3H, 1H, 4H. So not only we lack of 2 hydrogen, but 4 hydrogen lack. Propane has C3H8, propine has C3H4. That is why 2 elements of unsaturation as compared to propene and also cyclopropane. So one element of saturation means it has less 2 hydrogen as compared to the saturated compound. 2 elements of unsaturation means it has less 2 set of 2 hydrogen as compared to the saturated compound. So that's the meaning. Right. Let's move on. So here we have understood that a double ring represent one element of unsaturation, a ring represent one element of unsaturation, a triple bond represent 2 elements of unsaturation. Now we can see here there is an equation to help us to count how many elements of unsaturation is there in a hydrocarbon. So the formula is written here where the number of elements of unsaturation is equals to half times 2C plus 2 minus H. Remember, yeah? Half times 2C plus 2 minus H. So C here represent number of carbons and H represent number of hydrogen. Okay, let's see some exercise to practice that formula. So first exercise, if a hydrocarbon has 9 carbon atoms, so C9, 3 double bonds and 1 ring, how many hydrogen atoms must it have? Okay, so that's the first question. And the next question is, calculate the number of elements of unsaturation. So this one is using the formula implied by molecular formula C6H12. So you have the number of C, you have the number of H. You can simply use the equation just now. So this equation you can use to calculate the number of elements of saturation. And then give 5 examples of this structure. Let's see one by one. So the first one, question is, if a hydrocarbon, so we have one hydrocarbon that has 9 carbon atoms, so C9, but it doesn't tell how many hydrogen. Instead, they ask us to find the hydrogen. Okay, so it has 9 carbon atoms, 3 double bonds. You have to draw, it has 3 double bonds and 1 ring. Okay, so 3 double bonds, that is representing how many number of elements of unsaturation? So 3 double bonds. So double bond means there is 1 element of unsaturation. So if 3 double bonds, that would be 3 elements of unsaturation. And then we have another 1 ring. So 1 ring represent 1 element of unsaturation. That would mean we have 3 plus 1 here. So we have 4 number of elements of unsaturation. If we use the formula just now, if we use this formula, we can actually backtrack. We already know that this equation is equals to 4 elements of unsaturation. Where does it come from? The question mentioned that it has 3 double bonds, 1 ring. As you can see here, one double bond, one element of unsaturation. This 3 double bond become 3 elements of saturation. One ring, one element of unsaturation. So 3 from double bond, 1 from the ring becomes 4. So this equation is equals to 4. You know that C, in the question it mentioned that there is 9 carbon, and you can simply put 9. So half times 2 times 9 plus 2 minus H is equals to 4. Then you can find what is H. So see here, we can simply solve it by putting 4 as the final number of elements of unsaturation in hydrocarbon. Then you put into the formula, you will get H. So number of hydrogen is equals to 12. So that's how you use the equation. So let's see another equation. So the question is, calculate the number of elements of unsaturation implied by molecular formula C6H12. So this is very direct. What you're going to do, you simply put the number of C, which is 6, in the formula here, and the number of hydrogen, which is 12, and put in the formula. Solve it, then you found that there should be one element of unsaturation, but it doesn't mention what is the element. So as we see from the list here, one double bond, one element, one ring, one element, but a triple bond has two elements. Since the answer is 1, it's not going to be triple bond. The choice is only one double bond or one ring. So when the question asks, give 5 examples of these structures, then you can choose to draw any structures, but it must have one element of unsaturation. Either it's a cyclic, like these two compounds, we have hexane here, we have a methyl propane here, so it can be a ring, or it can be any structure. We have another ring here, and on the right, we have a cyclopropane here, or it can be either compound which is not cyclic, but it should has one double bond, not even two, one double bond only, because there should be only one element of unsaturation. So you have a choice on what structure you want to draw, as long as it fulfill the requirement, which is one element of unsaturation, and then the total number of C must be 6, total or number of H must be 12. Okay. All right, now let's move on to the elements of unsaturation with heteroatoms, because in hydrocarbons, they won't be only H and C. There are cases where we have also halogens, we have oxygens, nitrogen, and so on. Okay, let's say we have halogens. Now, what is the effect towards the elements of unsaturation, the number of elements of unsaturation? So halogens simply substitute for hydrogen atoms in the molecular formula. So let's say we have C2H6, which is saturated. See, this is simply an ethane, an alkane having 2C. So the formula C2H4F2 is also saturated, means all are single bonded. Okay, all are single bond. So we consider the presence of any halogen, we consider it as hydrogen when we want to calculate elements of unsaturation. So this is the case for calculating elements of unsaturation. Okay, so here we have 2C, 6H. So for the C2H4F2, F is a halogen. So in calculating the element of unsaturation, we simply consider F as H. So similarly, we have 2C and 6H as well for C2H4F2. So C4H8 has one element of unsaturation because it's like 2 of H as compared to the saturated compound. So we have another C4H5Br3. Again, halogen will be considered as hydrogen when we want to calculate elements of unsaturation. So we simply add up the bromine. The bromine here we have 3Br, 5H. So 5 plus 3, 8. So similar with C4H8. So it has one element of unsaturation. So let's see several structure at the bottom here. On the left bottom, we have saturated compound. So we have C2H4F2, where all single bonded only present. Okay, so it is the same as C2H6. And then we have the middle one element of unsaturation. We have C4H5Br3 as shown just now. So here we have one double bond, therefore one element of unsaturation, sorry. Then we have another. On the right hand side, we have C4H5Br3. So one element of unsaturation can be an alkene or the presence of a cyclic compound. So it can be the alkene in the middle here, or it can be a cyclic compound on the right side of the slide here. Okay, then we have oxygen. So now if you have oxygen, what do we do? What is the influence towards the number of elements of unsaturation? Okay, let's say we have an oxygen. So an oxygen atom can be added to the chain or added to a CH bond to make a COH group without changing the number of hydrogen atoms or carbon atoms. Let's say at the bottom here, we have C2H6. So this is the saturated compound that we know, the alkane. So 2C3H. What happened when we add oxygen? So if we add oxygen, we're going to add oxygen at the chain. So O will be in between two C. So O connected with the first C, O connected with the second C. And then we have two lone pair, top and bottom. So it's already fulfilled the octet. That is why only single bond is required. Then it's considered as saturated as well. So it did not, the presence of oxygen doesn't influence number of hydrogen and carbon. Nothing changed. We see another here on the most right, we have CH3, CH2. Just now in the middle here, O is connected in between two C, but O also can be connected in between C and H. So if it connected between C and H here, instead of having 3H at the C, since there is already O, H is connected at the O here and it's already received fulfill the octet lah. There is two lone pair, one with hydrogen, one with C, so it becomes 4 set lah. So it's also saturated. So this on top, the 3 element is already saturated. Let's see at the bottom. So we have CH3, COH. So we have a double bond. There is the presence of one element of unsaturation. There's another one which is the cyclic, COC. But then if we notice here, the number of hydrogen has reduced. At the top 3 structure, the number of hydrogen when having 2C is 6. So C2H6, C2H6O, C2H6O. But at bottom here, when there is one element of unsaturation, we have lack 2H as well. The O can be there or cannot be there. So the presence of O doesn't actually affect the number of element of unsaturation. It simply just will be added lah. So because of that, we won't change the equation for element of unsaturation. Now let's say we have a nitrogen. So what happens when we have a nitrogen? So a nitrogen atom can take the place of a carbon atom in the chain, but nitrogen is trivalent. Okay, so nitrogen is trivalent. What does it mean by a trivalence? Okay, trivalent here means, if you can see in the pink color, we have N here, nitrogen. Nitrogen is connected to 2C in the chain lah. It's connected with 2C. So nitrogen has 5 electrons at the outer layer. Thus we have here 3 covalent bonds. So trivalent. We have 3 covalent bond. 1, 2, 3. Trivalent. And then it has 2 lone pair. Thus it fulfills the octet rule. So additionally, it must have 1 additional hydrogen atom. So when we are calculating the number of elements of unsaturation, we count nitrogen as half a carbon atom. Because suppose in theory, we see the green color here. In theory, 1 carbon should have 2 hydrogen. But in the case of nitrogen, it only has 1 hydrogen. That is why when we calculate, we consider that nitrogen is half the carbon because it has half the number of hydrogen attached to it as compared to carbon. Okay. Right, so now let's test the equation. Consider this formula. We have C4H9N. And we have mentioned before, if we have 1 nitrogen, we consider nitrogen as half carbon. Okay, so instead of having 4C, we have 4.5C. The 0.5 comes from nitrogen. So C is equals to 4.5. Now let's put it into the elements of unsaturation equation. So elements of unsaturation is equals to half times 2C. C here is 4.9 plus 2 minus H. So 2 times 4.9 is 9. 9 plus 2 is 11. 11 minus 9 here. There is 9 hydrogen. 11 minus 9 is 2. 2 divided by 2, because times by half, right? We get 1 element of unsaturation. So it can be the structure at the bottom here. We have some example. We have 3 structures here. On the left hand side, we have 1, 2, 3, 4. We have 4C, where double bond present at the first C here. And then we must have nitrogen, 1 nitrogen. Then it can also be a cyclobutane here, where we have 1 nitrogen. Also, we can have like a straight line here, where we have nitrogen as well. And we have double bond as well. So there should be elements of unsaturation, which is 1 double bond or 1 cycle. Okay. So in summary, when we are calculating the number of element of unsaturation, we will count halogens as hydrogens. That's one thing. Second, we're gonna ignore oxygen, whether it's there or not. We're not gonna change the formula for elements of unsaturation. But if we have nitrogen, then we will consider number of hydrogen as half the carbon. So if there is 1 nitrogen, then we consider 0.5 carbon. If there is 2 nitrogen, then we consider there is 1 carbon, like that. All right, so you can try this exercise where you have to draw at least 4 compounds of C4H6NOCl. Okay, go back to the theory. Remember, if you want to proceed, you can stop the recording and try to figure out by yourself using this summary. Once you have tried by yourself, then you proceed the video. Okay, again, we have C4H6NOCl. So we have these 3 new elements apart from hydrogen and carbon. So we have nitrogen, oxygen, and a chloride, which is a halide. So here, if we have a halogen, we consider as hydrogen. So 1 chloride, then it's considered that we have to add 1 more hydrogen. We ignore the oxygen, so it doesn't matter. And then we have 1 nitrogen, so considered as half carbon. So we can modify this. So this C4H6NOCl is as if we have C4.5H7. Then we can put into the formula. So these are the 2 steps. First, counting the nitrogen as half carbon, ignoring the oxygen, count chlorine as hydrogen. So we have C4.5H7. So putting into the formula, remember back the formula. Here we have half times 2C plus 2 minus H. So if we do for the exercise just now, then we simply multiply 2 times 4.5, we get 9, plus 2, we got 11, 11 minus 7 just now, we got 4, 4 divided by 2, we got 2 elements of unsaturation. So, as mentioned just now here, so C4H6NOCl has 2 elements of unsaturation. So 2 elements, when we have 2 elements, remember back 1 double bond means 1 element, 1 ring, 1 element, but 1 triple bond, 2 elements. So you can choose, you can either show here on the left hand side 2 double bond to become 2 elements, or you can have two ring. So here we have two cycle, one with nitrogen, one with oxygen. So it can be the two rings to get two elements. It can be one triple bond because one triple bond represent two elements, okay? Or it can be a mixture of one ring, one double bond as shown in the structure on the most right in the slide. So you can choose, like you can draw any of it as long as it fulfills the requirement on the two number of elements of unsaturation. Okay, so that's about the elements of unsaturation. Now, let's see how do we name the alkenes. Okay, we actually already know how to name the alkene. It won't differ much, but let's see. We have some example here. We have IUPAC names and we have common names. IUPAC names in blue, common names in black. So first we have ethene here. We have 2C. So it should end it with ENE, representing alkene. And then we have 2C, so it become ethene. Then we have a propene, C3. Prop means 3C, and then ended with ENE, which means it's an alkene having a double bond. So here we have propene as the IUPAC name. We also have here the third structure here is a cyclohexene because it's in cycle form and there is 6 carbon. So hex, and then there is a double bond, so it's an alkene, so we ended it with ENE. So we have cyclohexene. So that's the IUPAC name. How about the common name? The common name for ethene is ethylene. Common name for propene is propylene. So aside from IUPAC name, common name, the IUPAC name has two type of IUPAC name. We have the old IUPAC names, we have the new IUPAC names. Both are accepted. So before this, in the blue name is representing the old IUPAC name, we put the number at the front. So for example, we have here a butene. So we have a butene is an alkene and that are 4 carbon, 1, 2, 3, 4. So which one will be the first carbon? The first carbon will be the carbon that attached with the double bond. So that is why 1 butene. So C having the double bond will be the first C. But new IUPAC name, we're going to put the number in between the prefix or the term that representing the number of C, and then we put the number, and then we will end with ENE representing alkene. So we have here but, which means 4C. Then we put the number where the double bond is present, so which is C1. So but 1 in, since it's an alkene. Okay, we see another example here on the right hand side. We have pentene 1, 2, 3, 4, 5, 5C. So all IUPAC name we start with number first. Since the double bond is at the first carbon, so we have 1 pentene. So new IUPAC name, put the number of carbon. We put the number of the carbon first, which is pent, representing 5, and then which carbon is having the double bond, which is the first carbon, then ENE. So that's how we name using the old and new IUPAC name. So these are another example. Let's say we have several double bond. Okay, we have several double bond. Let's see the first example on top left here. We have butadiene because it's an alkene, so we ended with ENE. There are two double bond, 1, 2. So diene. Di means two. Di means two. ENE means it has double bond. So two double bond present here. And then how many C it has? 1, 2, 3, 4. So but. So become butadiene. So which C is having double bond? So that will be the first C. We consider this one, not the second C lah. We don't write 2. We're going to make it the smallest number. So 1C and 3C. C number first and C number third. So 1, 3, butadiene. Butadiene. Okay, so that's the old IUPAC name. So new IUPAC name, simply we put the number in between the the word representing number of H, which is buta here. And then we have the number, which is 1, 3, and then diene, meaning there are 2 double bond. So we have the next structure here on the right. We have 1, 3, 5 heptatriene. In, because there is double bond. How many double bond? Tri. There are 3 double bond. 1, 2, 3. So triene, 3 double bond. How many carbon in total? Hept 5. 7. Okay. Hept 7. 1, 2, 3, 4, 5, 6, 7 carbon. So 7 carbon. At which carbon there are double bonds? Carbon 1, 3, and 5. So 1, 3, and 5. So we name it as 135 heptatriene using old IUPAC name, new IUPAC name. Simply put the number in between the word representing number of carbon here, which is hepta, and then put the number 135, and then how many double bond? There are 3, so tri. Is it double bond? So it's in, since it's an alkene having double bond. So we have hepta 135 triene. Another example, the last one, we have 1, 3, 5, 7. There should be 4 then. Cyclo, octa, tetra, in. Okay, from the back, it's in, E-N-E, which means it's an alkane. Then there should be double bond. How many double bond? Tetra. There should be 4 double bond. How many carbon is it? Octa. There should be 8 carbon in total. Cyclo means it's a cycle. There should be a cycle. Okay, which C are having double bond? 1, 3, 5, 7. So 1, 3, 5, 7. So we got the old IUPAC name, new IUPAC name. Simply we put the number in between the number, the name representing number of carbon, which is in this case cycloocta. Then we put a number at 1357. Then we end with tetraene. So based on the name, actually, we can imagine already how the structure look like. Okay. All right, so you can proceed with this exercise, do it by yourself. Remember just now what you're going to do. All right, you can start from the end, for example. I'll just show the first one. So we have a double bond here, then it should end with E and E. How many double bond? Only one, so no need to say diene, triene, tetraene. So it's just in there. And then how many C are there? Then you have to calculate how many C in the ring. So we have 5C. But additionally, we have a branch, which is a methyl there. So don't forget about the methyl. So we have methyl, and then we have the alkene as well at the first C. So you have to consider those in naming your structure. Okay, please do it by yourself and submit it later. All right, as I showed just now, alkene also can has branch substituents. So when we say substituents, is basically means is a branch. Okay, so alkenes can have a branch and can exist as the branch. So alkene can be the branch itself. So if you remember before, alkane, which is the saturated compound, only have single bond. When it is present as branch, as substituents, we will rename it as alkyl. Like this picture just now. Okay, we have this structure. The first left top, we have CH3 here, which is a branch. We will call it methyl rather than methane. Why? Because here alkane exists as a branch or a substituent. So instead of methane, we call it methyl. Similarly, alkene can be a branch as well. So it's not an alkyl, it's alkenyl. So alkenyl means a branch having double bond. Okay. So they can be named systematically. Like we have ethenyl, means there is 2C and it's double bond and it's a branch. Okay. Or propenyl, so there are 3C, there is double bond and is a branch, etc. Or by common names. Some common alkene substituents are vinyl, we have allyl, methylene, and phenyl groups. These are the common alkenyl substituents. So these are the 4 common alkenyl substituents. Branch, not mean. So we have a branch here. So how does these 4 common alkenyl substituents look like? So we have here this the curly line is the main line. So let's say if it can be like an alcohol or anything. So, but this is um, the main line lah, the parents group. Okay, so we have the parents group here. Then we have a branch. So now alkene act as the substituents is a branch. So we have one C only. So this is, and then we have the double bond. So this is methylene group. So this is the common name lah. We call this methylene group or methylidene group, methylidene group. If the branch, so this is the parents, so if the branch is having 2C, then they have a double bond here. We call this as vinyl group or ethanyl group because it means 2C and it has it has a double bond and is a branch, so it's ethanyl group lah. Vinyl group is the common name of the group. We have at the bottom here on the left 3C, 1, 3, 1, 2, 3. So if we have 3C with one double bond here, this group is called allyl group, or we call this as 2-propenyl group. Why? Because prop, 3 carbon, 1, 2, 3. And then 2. Why is it 2? Why is it not 1? Pause and think. All right, let's say you have proceed. We continue. Why is it 2? Remember that we have learned before. For the branch, this is a branch, which C we name as first C. The first C would be the C that attached to the parent. Okay, this is the parent. So this C that attached to the parent is the first C. So here will be the second and here will be the third. Okay, we will choose the smaller number. We will not choose the third. We will choose the second. Both second and third is having the double bond. So we choose the second lah. So we have 2-propenyl group. Okay, and the final common alkenyl group is phenyl group, where we have an aromatic structure. We have cyclic with double bond, so it's an aromatic lah. Okay, so that's what happened. That's how we name if we have alkenes as substituents or branch. So this is some exercise, but for this exercise, I think I'm going to show you how do we rename. So we have 3 structure here. Okay, 2 non-cyclic, 1 cyclic. Now, how do we name them? Let's see the first structure on top. We have the parents here. We have 1, 2, 3, 4, 5, 6. So we have 6, so hexa. And then the 6 in the parents, we have 2 double bond, so di, and it's an alkene, so di-in. So hexa, di-in. At which carbon does the double bond present? So first carbon and 5th carbon. So 1,5-hexa diene. Okay. Now let's see the branch. Okay, the substituents. So it has a substituents at the third C, 1, 2, 3. So this is the third C. We are not going to name this as from the right 1, 2, 3, 4 because then it's gonna be bigger number. So we will start from the left 1, 2, 3. So we have here the branch is attached to the third C. So 3-vinyl. Why vinyl? Because vinyl is the common name for a branch or an alkenyl having 2C. So that's why here we have 2C, right? So we have 3-vinyl 1,5-hexa diene. So this is the old IPAC name. The new IPAC name, you simply put the number in between name representing number of carbon, which is hexa here. Then put the number and then continue with diene, representing alkene having 2 double bond. Okay, that's the top. Bottom here, let's see, we have allyl chloride. How do we end it with allyl chloride? Because we have 3C, 1, 2C. So it's a if it's saturated and it's a propane, but it's alkene, so it's a propene here. But we have Cl here. If we consider it as a halide for a common name, then we will end common name having halide, common name for a hydrocarbon having halide. Remember, we will end the name with the halide name. So here, the name will be end with chloride lah. And how many C we have? 1, 2, 3. So we have 3 C. And then the first C is attached to carbon number 2. So we have allyl chloride, because C attaching with chloride will be the first C lah. So we have allyl chloride as the common name. That's why the color is black. You see the coloring here? Blue if it's old IUPAC name, green new IUPAC name, black name is the common name. So allyl chloride lah. We will end with halide. But if it's an IUPAC, then how we will name it? We will name it ended with the propene, because in alkene. So propene, because 3C propene, and we have a chloride here, we have chloro. So, but this time we will put 3C, because in this case, the main will be the double bond. So 1, 2, 3. See the difference, eh? Okay, then we have the third structure. So we have 2-phenyl 1,3-cyclopentadiene. So phenol, which is the aromatic compound here on the bottom right here, the blue one, the blue color structure is the branch. So this is the branch. So we have phenyl here. Phenyl is attached to carbon number 2. So we have here 1, 2, 3, 4, 5. So here it's 2 phenyl, and then the parent itself, how many carbon we have? We have 5 carbon, 1, 2, 3, 4, 5. So penta. How many double bond we have? We have 2 double bonds, so di, and there is double bond, so it's alkene, so in, cyclopentadiene. And then the double bond is at which carbon? Carbon number 1 and carbon number 3. So 2-phenyl 1,3-cyclopentadiene. For the old IUPAC name, new IUPAC name, put a number in between the words. So 2-phenyl cyclopenta 1,3-diene. Okay, that's how we name it. Okay. All right. Now we have, remember back when we learned alkane, we learned about cis and trans. Okay. We learned about cis and trans. So this is going to be the final, not final slide, final part of the lecture for today. So we have cis trans nomenclature. So before this, the tips was if the H, here we have H and another H here for the top left structure. So if H is at the same side, we call it cis. So in this case, cis-2-pentene or cis-pentotene, cis-pentotene. Okay, that's the tips. We see H and then the rest. So here we have methyl and then we have ethyl. Okay lah, this is cis. But if the H is at contrast position, so here H is at the bottom, H is at the top, then we call it trans-2-pentene lah in this case. Okay, and we have another 2 structure at the bottom. Okay, the bottom here we see top left. Okay, sorry, bottom left. So bottom left in this square here, the rectangle shape here, we have C double bond C, and then the first C that having double bond has 2 methyl. And then the second C that having the double bond has 1 H and 1 ethyl. Now how? It's neither cis nor trans, because the tips before is we will refer to H. We will refer to H. So if H is in the same side, cis, H is in contrast, then it's trans. See another shape, another structure on the right bottom. Here we have C double bond C. The first C has only hydrogen. The second C has 1 propyl group and then 1 hydrogen. So they are neither cis nor trans because the structure is now different. So okay lah, so we know this is cis, this is trans, these are not cis or trans. Now we have a situation where we have a new naming, okay, new cases. We have easy nomenclature. So how is that? So we consider this structure. So we have 2 structures here where we are considering halide as well, okay, halogen as well. We have halogen as well. So we have BrCl attaching to the first C, and then we have methyl and hydrogen attaching to the second C. Similarly, we have the same compound attaching to the first, same compound attaching to the second, but the position of Cl and bromide here is in contrast position already. Okay, so now how? Okay, now we have an easy nomenclature. Z isomer from German words Zusammen, which means together, is a cis. Z is cis, cis lah if you want to remember. And we have E, isomer from the German word antigen, which means opposite. So E acts as trans. So Z is cis, E is trans. So just to ease our memory, maybe just remember this directly. So automatically E will be trans. Okay, so now how? We have a rules called Kahn-Ingold Prelog rules. These three people create this rule. Okay, so the idea is atoms with higher atomic numbers receive higher priorities, because now we want to classify it, whether it's cis or trans. But in this case, we don't call it cis or trans. We call it, is it E or Z? Okay, so we have to number them in order for us to know whether it's E or Z. Okay, now look, we have this structure. We have a C attaching to 4 different atoms. Okay, F, CH3, so it's attached to C. And then we have H, and then we have nitrogen, N. Okay, look only at the atomic number of the atom directly attached to the asymmetric carbon, not the entire group, which means when you see the atom, attaching to the C that you want to number, so here is in the middle is the C, we see directly the atom, not CH3, we see C only. We don't see NH2, we see N only. Now, how is the priority? So at the bottom here, we can see the priority list. So this is the standard priority lah. So the highest priority will be for I, that followed by BR, and then CS, and then S, F, O, and 13C, 12C, lithium, 3H, 2H, 1H. So how does this was sorted? So it depends on the atomic number lah actually. So this is the priorities. The most left will be higher prioritized lah. Okay, let's see an example. Okay, before that, let's say all are the same atom. So because we are referring to only atom, right? So if in the middle we have C, of course in the middle we have C, and then we have the atom attaching with C, there should be 4 atoms, 1, 2, 3, 4, and 3 of them are C. C, C, C. But it's actually here is ethyl, we have ethylene bromide, and here we have a branch. So, but there are 3 C. Now what happened? Okay, so if in this case, in case of ties, because it's the same, we use the next atoms along the chain of each group as tiebreakers. What does it mean? Okay, let's see an example at the bottom here. The highest priority will be on the left, the structure on the left. We have CBr, C attaching to H, HBr. This structure is attached with the middle C. So here, where does this, how do we imagine this? Here we have CBr, right? This C is attaching to the main C. The main C is here. I hope you see. Okay, you can see my mouse. Huh? So the main C is here. This is main C with a star. This is C star. So C star is attached here. This is C star. Beside C star, we have C. That's why we are confused. It's ties. So this is the C beside the C star. This C have BR. So remember back, this is the priority of atoms. The most prioritized is I and then BR. So that is why, in this case, this group will be higher priority. We have the second group, which have lower priority, which is C, where the next atom is Cl, even though there are 2 Cl, even though there are 2 Cl attaching to the C, but because the priority Cl has lower priority than Br in this trend, Cl is having lower priority than Br, even though there are two C, it still become a lower priority. That is why it's number 2, lower. And then we have C, attaching to the C star, having another metal, 3 metal even, not just 1, not just 2, but 3 metal. But still, because remember here, the flow must be the halide first, then C, then H. So because C is in the middle of the trend, so it has even lower priority than Cl lah. Then lower than that, we have the C is attaching with the C star here. That C attaching with the C star have 2 C, 1 H. Okay, you notice here, one of the C have Br, but we don't care about that one. We care about the C only. So this C1, C2. Here, the previous one that we mentioned, it has 1, 2, 3 C. So bigger number of C. So even though this one having the Br have Br, but because only 2 C it has as compared to this one, then it has lower priority lah. Okay, the most lowest priority is a branch having C that connect with 1 C. Oh, so here again, here there are 3 C, 2 C, 1 C. Then we don't care what is after that. So that's how we sort the priority trending. So how do we use this priority? Yeah? So how do we use? Okay, go back to the Khan in gold pre-lock rules. Okay, we go back with these rules and then we combine the idea just now lah. Okay, now how? Treat double and triple bond as if each were a bond to a separate atom. What does that mean? Let's see 2 examples. Well, the 4 example here to understand what does this sentence mean. Treat double and triple bonds as if each were a bond to a separate atom. We have on the top left here 2 C, which having the double bond. So what do we have to do? We have to break the bond, break it and duplicate. What does it mean by duplicate? Compare the top and bottom in order to understand. Top, we break, so it become C, single bond, C. From double bond, we break one, become single bond, C, C. Then this C, before this, first C attached with second C. So here after we break, we duplicate. First C attached with second C. First C attached with second C, right here. Second C attached with first C. Second C attached with first C. Second C attached with first C, duplication. Okay, to understand more, see at the bottom, we have C double bond N. Okay, break and duplicate. Okay, let's break double bond becomes single bond. Let's duplicate. C attached with N. Okay, C attached with N. Duplicate. C attached with N. N attached with C. N attached with C. Duplicate. N attached with C. Okay, this is what break and duplicate means. This is example for double bond. Now let's see triple bond. Okay, break and duplicate. But this time we have to break 2 times because they are triple bond. Okay, break and duplicate. Break 1 time, break at the bottom again. So break twice and duplicate. So do we have to duplicate twice lah? First C, second C. First C attached with 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 second C. So triplicate lah in this case. Okay, not only duplicate, we triplicate. Similarly, second C attached with first C. Second C attached with first C. Second C attached with first C, duplication. Second C attached with first C, triplication. Okay, do the same for C double bond O to understand. So this is duplication lah because double bond only. C, O. C attached with O. Okay, break first. Okay, C attached with O. And then O attached with C. Break, duplicate. O attached with C. So this is the break and duplicate rule. So how do we work with this? Let's see the exercise. Remember back all the ideas that we learned just now. We have this C. Okay, remember back the rules just now on the priority. We have here C, C, and H. So based on this one just now, N come first, then C, then H. So here we have N come first, then C, then H. Okay, N and H we understand lah. But how about C? We have to see the adjacent atom. So this C attached with H, this C attached with O. Okay, go back to the trending. So O comes before C and H even. So that is why in this structure, this COOH become number 2, the CH3 become number 3. You understood that, eh? If you don't understand, you simply pause the video and try to understand and continue again. Okay, now easy nomenclature, okay, the one that we have discussed. Now let's see here, okay? Again, remember we have E, we have Z. To make it the same idea with the cis trans, just remember this, okay? Z means cis or same side. So we have Zusamen here. Zusamen have the same side for priority 1. This is the priority that we are numbering just now. 1. It's not an atom here, it's a priority. So the first priority is at the same side, then this is cis, or Zusamen, cis, or similar, same side. Then we have a trans here, or E, antigen. So here we have 1 here, in contrast 1 is here, so it's E, okay, or trans lah. All right, so this, which means the same priority is in contrast position. Okay, this is same priority is at the same position. Okay, this is an example. Okay, remember back the trending just now, we start with the halide, but bromide comes first. So bromide is number 1. Chloride is number 2. Okay, we evaluate one side already. Bromide 1, chloride 2. Let's evaluate on the right hand side. C come first, then H come. So C number 1, H number 2. You see, bromide and CH3 are both first priority for their respective C. We're gonna evaluate it separately. Yeah, we're gonna evaluate it separately. First the left and then the right, or the other way around. Okay. So 1 on top, 2 on the bottom. 1 Br, 2 Cl. 1 CH3, 1 H. 2H, sorry. So because 1 are both at the top, then it's this, Z or cis, or same side. So we call it as Z, 1 bromo, 1 chloro, propene. So the naming afterwards, you can actually find by itself lah. 1 bromo here, 1 bromo, 1 chloro. Then we have 3 C, that's why prop. We have chloride, 1 chloro, okay, prop in, because there is double bond. Now let's say at the bottom here. Okay, this is contrast. Why? Because following the trending, what trending am I talking about? I'm talking about this trending. Example of priority should come with the first priority is I, then BR, then CL. So you have to memorize this line. I, BR, CL, then comes O, C, and H. Okay, go back to the structure just now. So now the top will be second priority, 2 CL, 1 BR. While on the right-hand side, just now was left-hand side, on the right-hand side, C is the priority, the first priority, H is the second priority. Now we have a contrast. Left-hand side, 1 at the bottom, right-hand side, 1 at top. So since it's a contrast, it's a trans, or is it an E? So E, 1 bromo, 1 chloro, propene, okay? So that's how we name the easy nomenclature, right? So this is an example, some exercise, okay? Just we see one more example and we will end the session. So we have here, we will consider one side by side. Let's see the, on the left-hand side here, we have, if we separate it, first we consider the cycle. So we have C here, we have C attaching to 2C. So the first is C, second is also C. So if we have a tie, say C having double bond is attaching to both C, then we have to see adjacent atom. So at the top here, we have C connecting with O. At the bottom, we have C connecting to C. So the first priority will be the one connecting with O. So we write this as the first priority. The bottom here will be the second priority. Okay, settle with the left. Now we go to the right. So go with the right. Similar, we have C attaching with C and C. Then we see the adjacent. Okay, at the top, C is attaching with H. Bottom, C is attaching with C. So following the trending just now, those with C attaching with C has higher priority. Now the number become 1 at the bottom, 2 at the top. So in contrast, it become trans or E isomer. If we switch, now become the C having the oxygen will be the first priority. We know already, like explained just now, C having C will be the second, so that's for the left. While for the right, because they switch the structure already, so C having C will be the first priority, C having H will be second priority. Now the priority is the same side, we call it as cis or Z, cis isomer. Okay, so that's how we name. You can do the exercise by your own and solve it to draw it. Okay, so I think we will end the session here. You can always refer back to the recording, try to re-understand it, pause and repeat if required, and I'll give you exercise to increase your understanding. So thank you very much everyone for attending. So we'll see you again on the next lesson. Goodbye everyone.